Here's a short clip on how we use a particular formula, this one here, to calculate what's called Spearman's rank correlation coefficient. Now we sometimes use Spearman's rank correlation coefficient in preference to Pearson's one, the commonly known R statistic that we've been using in this course so far, under certain circumstances. For example, if there are some serious outliers in a set of data, or if we are not looking at a normal population of scores, then Spearman's rank correlation coefficient is preferred. All it does is, instead of finding an R statistic for normal pairs of data, such as we're looking at here, it finds the correlation coefficient for the ranks. So the idea behind Spearman's rank correlation coefficient is that we rank the data sets and find an R statistic based on that. Alright, so imagine in this case we have a diving competition and we want to examine the scores allocated by a particular judge. We'll call him Judge A. And we're going to compare the scores he allocates in a diving competition to the scores allocated on average by the other judges. You know, there might be 4 or 5 judges in a scoring panel, so we're comparing Judge A with the averages of the scores allocated by the other judges. So here are the scores here. Judge A has allocated 6 scores to 6 competitors as follows: 6, 6.5, 7, 7.5, 8 and 9. And that compares with the scores allocated by the other judges on average of 7, 6, 6.5, etc., etc. Now I hope you understand what's going on here. We have 6 competitors, so that for the first competitor, Judge A allocated a mark of 6, whereas the other judges on average allocated 7. Alright, so what we do to use Spearman's rank correlation coefficient is we rank the scores. So in this column here, rank A, what I've done is say what rank each score is. So the lowest score awarded by Judge A was 6, and that lowest score gets a rank of 1. We always rank from lowest to highest, not the other way around. The second lowest score, I should say, was 6.5, and it gets a rank of 2, etc. So you can see that the highest score allocated by Judge A was 9, so it gets a ranking of 6. And we do the same thing for the scores allocated by the other judges. So, and you can see how I've done that in the rank others column. The lowest score was 6, and so that gets a ranking of 1. Okay, now what we do from here is we find the rank differences, because what our formula is telling us to multiply the sum of the differences squared by 6. So what are these differences squared? Well, what we've got to do firstly is find the rank differences, and that's in this column here. All it is the rank A score minus the rank others score. So 1 take 3 is negative 2, 1 take 3 is negative 2, and then we're going to square it. Okay, we do the same for each other pair of scores. 2 take 1 is 1, and 1 squared is 1. For the last competitor, Judge A ranked that score 6 highest, or sorry, 6 from the lowest, and as did the other judges combined. So 6 take 6 is 0, and 0 squared, of course, is 0. What we do now is we simply total the D squared column. And when we do that, we find that the total is 8. Okay, so that big symbol there, sigma, means the sum of the D squareds. And so now we're ready to use the formula, noting that the value of n is 6. Why 6? Because n means the number of pairs of scores, and there were 6 pairs. Okay, and you know, you can tell that from the first column that there were 6 scores. All right, so using our formula, we would firstly go 1 minus 6 times 8, because as we've seen, the d squared, the sum of the d squareds, I should say, is 8, and that's all over 6, because as I said, n was 6, the number of competitors was 6, bracket 6 squared minus 1. That gets us to this stage here. All right, now the rest of it's just tidying up. So, RS, the Spearman rank coefficient, that's what we call it, R subscript S, is equal to 1 minus 48, because 6 times 8 is 48, over 6 times 35. Why 35? Because it is 6 squared minus 1. Okay, so we've got 6 times 35. Therefore, R equals 1 minus 48 on 210. And using our calculator, we discover that R subscript S will equal 1 minus 0.2286, and therefore the Spearman rank correlation coefficient will equal 0.77 to 2 decimal places. So that's telling us that there's a fairly strong, I wouldn't say very strong, but I'd say fairly strong correlation in the scores between Judge A and the other judges. And the correlation is positive, as you would hope, so that means that generally speaking, as the scores for Judge A increase, so do those for the other judges on average. The correlation is not perfect, but I would say it's fairly strong. Thank you, and that's how we do Spearman's rank correlation coefficient.